Let's take some notes on the law of conservation of energy. Number one, energy cannot be created, nor can it be destroyed. It can only change form. So energy can be moving from kinetic to potential, potential to kinetic energy. It can be moving between potential mechanical energy to kinetic mechanical energy, or even from chemical to mechanical, or any real form of energy. It can change between them, but it cannot be created and it cannot be destroyed. So energy, when we think about it being lost, it's really not just vanishing. It's more often than not turning into heat. And some of that lost energy, when we say heat energy, we mean like, think about a light bulb, for example, right? It's electrical energy turning into light energy, radiant energy, but it feels warm. And that's the lost, quote unquote, lost energy. That's thermal energy. So what we're mostly going to focus on this unit is between kinetic and potential energy. Here are some examples of other kinds of energy conversions or energy transformations. If you are burning a candle, it is chemical energy being converted into heat energy and light energy. If you have fuel, so when we talk about fuel, we mean like, think about the gasoline, the petroleum in your car, right? That oil, the gasoline is chemical energy. As it's getting burned, you are getting heat energy, right? It warms the car. If you've ever felt the hood of a car, it's hot. But there's kinetic energy as you're moving. That car is moving. And there's also electrical energy, right? Like, think about all the things in your car that run on electricity. So it's all of those things happening. A nuclear explosion is an example of nuclear energy getting converted into heat and light energy. Or a spring, right? A spring or like a slinky. That's elastic potential energy, so the other type of potential energy. And then when you let go of that spring, it turns into kinetic energy. So when stored energy begins to move, the object's energy now transfers from potential to kinetic energy. So if you're standing still, you have the potential energy, the potential to move. And then as you begin to run, that gets converted into kinetic energy. You can have both, and you oftentimes do have both at the same time. Okay, and we're going to practice how to do those calculations. As far as the math that we do, we are only going to do the math going from kinetic energy to gravitational potential energy, specifically when the height of an object changes. So imagine something that is falling or getting thrown, something like that, because those calculations are very, very simple, and they use the equations that we have already learned. So common examples are like roller coasters. That's another one. We talked about falling object, maybe like a ball falling, but a roller coaster is another big one, right? As you move up and down on the roller coaster, your energy goes from potential energy at the very, very top to maximum kinetic energy at the very bottom. And then you have a little bit of both when you're either going up or coming down somewhere in the middle. Or let's say somebody's skydiving, right? As they are at that peak of their height, as they're about to jump out of a plane, you have maximum potential energy. And as they move closer to the ground, their height decreases, so their potential energy decreases, but they speed up, they move faster and faster and faster, and their kinetic energy increases. And then they have maximum kinetic energy all the way at the ground. So when the object is at its highest position and not moving, it has maximum gravitational potential energy, and its kinetic energy is 0. I don't know if you've noticed this, but if you take a ball and you throw it straight up, at the very, very, very highest moment that ball is at, when it's changing direction from going up to coming back down, the ball stops moving for just a quick second. And at that moment where it's not moving, that's when it has 0 kinetic energy. It's also where it's at its highest point and has maximum kinetic energy. Sorry, maximum potential energy. Then the object begins to fall back down. And as it falls, the gravitational potential energy decreases because the height decreases. And when it's falling, it is speeding up. And as it speeds up, the kinetic energy is also increasing. So as gravitational potential energy decreases, kinetic energy increases. So they are opposites of each other. And finally, at the lowest position, basically when the height is 0 meters, before it hits the ground, or rather the moment it hits the ground before it stops moving. And these are all really very quick things, right? They're things that are really hard for our eyes to catch. But there's a moment in this example where the ball hits the ground, so its height is 0, but it's at top speeds. And that is when kinetic energy is at a maximum. But because the height is 0, the potential energy, the gravitational potential energy, is also 0 joules. So let's go ahead now and switch to doing some of that math with this, okay? So this practice problem says the fruit of mass 5 kilograms is found growing at the end of a tree branch 20 meters above the ground. And it says, number 1, calculate the energy of the fruit. What form of energy does it have? Let's draw a picture quickly to kind of visualize what we're looking at. I'm going to draw this picture above the problem. So I have this tree. It's a purple tree. And here's this, it's got like a branch coming off of it. Okay, that's a terrible branch, but that's the branch. And there's this, I don't know, it's an apple, okay? It's an apple. This is the ground. So this height right here is going to be this 20 meters, okay? And we know, this is the 20 meters it describes right here, and we know that the fruit has a mass of 5 kilograms. So our two potential options when we are doing this math is to either look at gravitational potential energy or kinetic energy. These are my two options. And something that's really, really, really important to highlight is that my total energy is these two combined together, okay? So we are going to figure out, sometimes one of them will be 0, and if potential energy is 0, then kinetic energy and total energy are the same. Or if kinetic energy is 0, then potential energy and total energy are the same. But regardless, when you combine them, your total energy never changes. This total energy cannot change because of conservation of energy. Remember that conservation, conserve, means to save. So if I look at this picture, go back to my problem, I see that this fruit is not moving. So if the fruit is not moving, it's just standing there. If it's not moving, then my kinetic energy must equal 0 joules because it's not moving, which means all of my energy must be potential energy. What form of energy? Well, it must be GPE because it is a high off the ground, 20 meters off the ground, and it's not moving. It has the potential to fall, but it's not falling. So I'm going to calculate this. GPE is equal to mass times gravity's acceleration times height. Well, I know that mass is 5.0 kilograms, which I know because kilograms is the unit for mass. We know that G is always 9.8. The problem never tells us that, but we have not forgotten. 9.8 meters per second squared. And then the height is 20 meters off the ground, because remember, meters is a unit for distance, and distance and height are the same thing. Now we can just use our equation and do this math. So GPE equals, that's a G. M is 5.0 kilograms times g, 9.8 meters per second squared, times a height of 20 meters. And I multiply all three of those together, and give me a second. 20 times 9.8 times 5. I get 980 joules of gravitational potential energy, which right now is also the total energy. Because remember, I have 0 joules plus 0 joules of Ke. So my total energy is also 980 joules. It tells me the same fruit falls to the ground. What is its GPE now? Well, remember, GPE is mass times gravitational acceleration times height. My mass, that's the same, 5 kilograms. My gravitational acceleration is still 9.8. That's the same. Oh, but look at my height. My height at the ground is now 0 meters. If my height is 0 meters, I have mass 5 times gravity's acceleration 9.8. So 5 times 9.8 times 0. Well, anything times 0 is 0 joules. Which means at the ground level, my total energy is equal to now kinetic energy. Because remember, total energy never changes. So if total energy, total E, is equal to GPE plus Ke, well, total energy is 980 joules. That doesn't change. GPE is now 0, which means kinetic energy must be all 980 joules. It fully transferred from potential energy to kinetic energy when it fell to the ground. So that's how that transfer of energy works. It says calculate the gravitational potential energy and the kinetic energy when the fruit is 5 meters off the ground. Okay, great. So we're going to have to do a little bit more math here. So first of all, we now know that our height has changed, right? Our mass has not, and our gravitational potential energy has not, but our height has changed. So let's go ahead and write that. Mass, I'm going to use the other color. Mass is still 5.0 kilograms. That's not changing. Gravitational acceleration is 9.8 meters per second squared, but my height is now 5 meters. Okay. So my GPE, I'm going to multiply 5 times 9.8 times 5 meters. Let me confirm that this mass is 5. Yes, mass is 5. Okay. So I multiply those together, and I get my gravitational potential energy to be equal to 245 joules. All right, so this is the step that's a little bit new. Our total energy, remember, our total energy up here is 980 joules. And we know that total energy, I'm going to write this kind of off to the side here, total E is equal to, can I squeeze it, GPE plus Ke. So total energy, we know, total energy cannot change because law of conservation of energy tells us it does not change. So total energy is 980 joules. So I'm going to plug all of these numbers into this equation. 980 joules is total energy is equal to 245 joules from gravitational potential energy plus some amount of kinetic energy. Well, how do I solve for this kinetic energy? I'm going to subtract. The opposite of addition is subtraction. So I get kinetic energy. Let's use a new color here. kinetic energy now is equal, so this side cancels, and I get 980 minus 245 equals 735 joules. So my answers here are gravitational potential energy equals 245. How did I get that? Oh, whoopsies. I don't know how I did that. Whatever, I'll leave that alone. And my, what did the problem say? And my kinetic energy is going to be right down here. Okay, there we go. That is that answer. Final thing, sum up sum means addition. Okay, if it asks for the sum, it means you are adding up both gravitational potential energy and kinetic energy and compare the value with your answer to question 1. Okay, so GPE was 245 joules. Kinetic energy was 735 joules. I add these up and I get 980 joules. This is my total energy. I go back to question number 1. Question number 1, I got GPE equals 980, and we also kind of added that kinetic energy was 0. Amazing. What do I notice? Well, that means I noticed in number 1, all energy, I'm going to use a big E for energy, was gravitational potential energy. B/C is because the fruit was not moving. As the fruit fell to the ground, energy converted from gravitational potential energy to kinetic energy. There you go.